So we have a torque wrench. We attach a rope at 9 inches or 0.75 feet from the pivot point. The way a torque wrench works is once it reaches the desired torque, a mechanism inside the torque wrench will click, which means the desired torque has been applied. So in theory, if we hear a click at two different measurements, then the torque between those two measurements are the same. We pull the rope at a 90-degree angle and get a measurement of 10.7 pounds force when the torque wrench clicks. What force will be needed to get the torque wrench to click if we pull at a 30-degree angle from the initial measurement? To complete this problem, we will need to break the force going at a 30-degree angle into vectors, and we will need to know a little bit about trigonometry. We will need the same force vector acting perpendicular to the handle of the torque wrench when the angle is 30 degrees from initial measurement. So this means that the leg of the 30-degree force vector that is going perpendicular to the handle will be 10.7 pounds. So now we have a right triangle that we can use SOHCAHTOA and set the cosine of the angle equal to the adjacent over the hypotenuse. Next, we can plug in our angle of 30 degrees in the adjacent leg of the triangle of 10.7 pounds force. Now we can rearrange the formula to get the force to one side. We are left with the force being equal to 10.7 pounds force divided by the cosine of 30 degrees. After plugging in all of our numbers into the calculator, we get a force of 12.35 pounds. I completed a quick and dirty experiment where I pulled it at a 30-degree angle from the perpendicular. I ended up with a pull force of 12.29 pounds. This gave us an experimental error of 0.5%, which is well within the realm of experimental error. Honestly, I'm surprised at how close this is to theoretical value given the measurement method. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Thank you for watching.